This is the prerequisite review for section 2.8, Algebra of Functions and Function Compositions. So this first objective is the domain of a function, and the second objective is going to be function notation. Now, let's go ahead and take a look at number 1. Here we will find the domain of this rational expression. So the goal is to start with all real numbers and exclude restricted values. So we start with everything, and then we go ahead and we remove any values that we can't include. So here, as you can see, we do not want the denominator equal to 0. So we go ahead and set the denominator equal to 0, and we see that x equal to -6 is a restricted value, but all other values of x are okay. So what we want is we want all real numbers except for -6. So let me go ahead and make this solution set like this. We don't want -6, but we want everything greater and also everything less. So let me go ahead and move this right here. And now we will go ahead and write an interval notation. We have -infinity to -6, and then we'll start on the other side of -6 and go all the way to infinity. And this is the domain of that function in number 1. Looking at number 2, g of t, we just want to look at that denominator, and that denominator would be equal to 0. If it would be, that would be a restricted value. And so let's go ahead and make our number line. And there is 0. And we don't want 0, but we can have all other real numbers on both sides of 0. And again, this is an open circle. So here we have -infinity to 0, union 0 to infinity. Now, under a square root, we have to remember that what is under the square root cannot be negative. Or we could take it the other way. We could say that a minus 3 needs to be greater than or equal to 0. Adding 3 to both sides, a has to be greater than or equal to 3. So there's a couple ways you can do this. So here we have 3, and we want everything greater. And so here you could actually say x cannot be equal to -6, and t cannot be equal to 0, if that might help. So here we're going to go ahead and say from a to infinity. That is our domain. It's a little different because we didn't have a value, but oops, we have a value. We want a greater than or equal to 3. So 3 to infinity is our domain. Okay, let's do the same thing here when we have a square root. What we're going to do is we're going to say a plus 2 needs to be greater than or equal to 0. Subtracting 2 from both sides, we need a to be greater than or equal to -2. So going ahead and making a number line, we can see that 2, negative 2, and everything greater. So we have negative 2 to positive infinity, and that is our domain. Okay, taking a look at number 5, we're going to do the same thing again. 12 minus 6x needs to be greater than or equal to 0. Negative 6x needs to be greater than or equal to negative 12. I just subtracted 12 from both sides. And then I'm going to divide both sides by a negative 6. Keep in mind that we will have to reverse our sign. And so we end up with x, let me be in this different pen. We have x is less than or equal to 2. So with that, we have that number line, and we want all of the x values that are equal to 2 or less than. And that is because we had to reverse our sign. So here we have negative infinity all the way to 2, and we do want to include 2. Okay. I think if I take this off here, this might be a little bit easier. And then I can just put this under here. Okie dokie. Okay, let's look at number 6. Now we do not have a square root. So let me write that up here. No, what we need to look for is 0 can't be in the denominator, and also negative numbers can't be under a square root. So those are the things that we're looking for here. So we had 0 in the denominator in number 1 and number 2. And then in number 3 through 5, no negatives under a square root. Well, we don't see either of those in number 6 or number 7. There's no denominator, there's no square root. So when you have that case, it's all reals until we get to logarithms. So the domain here is all real numbers. Okay, and maybe I should extend that down just a little bit. And now let's look at number 8. Not only do we have a denominator, but we also have a square root. So we have to take care of both of these. So what we're going to do is we're going to say x plus 2 has to be greater than or equal to 0. So we need it greater than or equal to 0 for it having no negatives in the denominator. But we also don't want 0 in the denominator. So we now have to take the equals off. So we need to make sure that it is just positive. So no negatives. Whoops. No negatives. And in the denominator, we can't have 0. So x has to be greater than negative 2. So drawing that number line, if you see here, we have a negative 2, and we want everything bigger. We don't want negative 2 because it's greater than. So we would have negative 2 to infinity as our domain. Same thing here with number 9. 4 minus x needs to be positive. That takes care of the denominator and the square root. So we can't have a 0 in the denominator, and we can't have a square root with a negative. So let's subtract 4 from both sides, and now we're going to multiply by a negative 1, and of course we're going to have to reverse our sign, and we will have an x is less than a positive 4 because we're multiplying by a negative. So having that number line, we can see that we have a 4, and we want everything less. So we have negative infinity going all the way to 4. And that's our domain. Okay, that was a lot. So we do need to just practice those, but we're looking for square roots and denominators. Okay, now we're going to talk about function notation. And here you can see we are given a function, and here we are trying to evaluate the function at a certain value or expression. And this is really good practice because everywhere we have an x in f, we are going to put x plus 1. So f of x plus 1, you can see right below that, is 6 times x plus 1 minus 2. We'll go ahead and distribute that 6, and we end up with 6x plus 4. Okay, let's go ahead and look at this next one. Given g of x is 3x plus 5, this time our x is going to be w plus 4. So g of w plus 4 is going to be 3 times w plus 4 plus 5. Let's distribute that 3, and we have 3w plus 17. Now, finally, we are going to find h of x minus 2, and this is a little more work because here, everywhere there's an x, we're going to put all of x minus 2. So we're going to take x minus 2 and square it, 3 times x minus 2, and then subtract 1. So each one of these x minus 2's have been inserted where there was an x. So if we square x minus 2, I'm just going to put a little star over here. X minus 2 squared is equal to x minus 2 times x minus 2. First, outer, inner, and last. And we will combine our like terms, and this is what we get. So it's just a little bit easier to come over here and work that, and we have x squared minus 4h plus 4. Now let's distribute that 3, and we don't want to forget about that minus 1. Combining like terms, you can see here we have a negative 4h. Whoops. We have, that should be an h minus 2 squared. I don't know why I did an h. Probably wondering what in the heck. And so now we have combining like terms, x and an x, and then we have some numbers we can combine. So we end up with x squared, and it looks like we have minus 1x, and then we have minus 3. And let me see if I can draw that. That concludes this worksheet.